Okay, Trig, section 4.3, sines, cosines, and tangents. Sometimes we refer to this as the unit circle of fire. Muhaha, muhaha. Okay, enough of Finding Nemo. The unit circle can be tricky. It's not awful, but you know, if you don't pay attention, it is not something you need to memorize, as so many students think they need to. If you understand right triangles and some basic right triangle, geometry, it is very, very simple. The Greek letter theta, looks like a circle with a line through it, is used for angle measurements. Every coordinate on the circle has an x value and a y value. It's called a unit circle because the radius is 1, and every point on the circle has some kind of rotation or angle theta. If you look at the right triangle that I've drawn here, this side of the triangle has side length x, and this side has side length y. If you use your basic SOHCAHTOA stuff, remember that? You're dealing with cosine, that is the adjacent side divided by the hypotenuse. Adjacent over hypotenuse gives me just plain old x. Sine is opposite over hypotenuse, that's opposite y over hypotenuse 1. And so we get the sine of y sine of theta equals y. And then tangent is opposite over adjacent, so opposite would be y and adjacent would be x. Now, what you really need to understand based on that information is that cosine is an x value, sine is a y value, and tangent is y over x, and that is the slope of the line, rise over the run. So every coordinate on the circle can be figured out by using the cosine of theta for the angle and the sine of the theta for, so this location, there is an angle of rotation in quadrant 3 that we could use to find that particular location on the circle. Now, there are some basic points on the circle that you need to know. I call them the kindergarten points. They are points like over here at the radian measure 0, 1, 0, and at the top 0, 1. And on the left, -1, 0, and at the bottom, 0, -1. Sorry, couldn't see it, I'm sure. Those are the basic, right where the quadrants come together, right on the x and y axis, that kind of thing. So they're the easy ones. I'm going to ask you for the cosine of pi. Evaluate the cosine of pi. I'm asking you to go to a particular place on the circle. In this case, that place would be the far left where pi sits, and to identify the x value. Oh look, it's -1. Therefore, that's my answer. So you need to know where the angle is, and you need to know whether you're dealing with an x value, or a y value, or the slope. So if it says evaluate the sine of pi, you're going to find pi and identify that its y value is 0. What about the tangent of pi? That would be the slope of the line that extends out this way. Well, that slope is 0, right? Well, and hopefully you understand other things like if you were dealing with -270, keep in mind what that is, right? Starting around here, we got -90 and -180, -270. That's a vertical line, and vertical line has no slope or undefined. Okay? Well, let's say I say find the coordinate with 18-degree rotation. That's kind of a weird number, 18 degrees. Well, here's your no-calc answer. Cosine 18, sine 18. That is your no-calculator answer. Pretty easy. If you had a calculator, with a calculator, you could actually type those values in. Now, I would say to you to make sure that your calculator is in the correct mode. If you hit the mode button, make sure your calculator says degree if that's what you're using. So that when you come back here and you hit cosine 18 degrees and sine 18 degrees, you can come up with the correct values, like 0.951 and 0.309. Now, I would like you to switch your calculator into radian mode, so come back to the mode button and come down here and change it into radians. And then I want you to answer these two questions. Give me the no-calc answer for a rotation of 3 pi over 5 radians and a calculator answer. So, kind of a generic one, and then one with a specific, with actual approximated values to the thousandths. If you think about this, think about the quadrants. Every point in this quadrant has a positive x and a positive y. That's a positive cosine and a positive sine. Well, if you think about it, everything on this half of the circle has a positive x value. Everything on this half of the circle has a negative x value. Everything on the top half of the circle has a positive y value. And everything on the bottom half of the circle has a negative y value. Now what about the slopes? The slopes of these lines in these two quadrants. The slopes are going to be positive here and a positive slope there. What about the slopes of these lines? That's a negative slope. Sorry. It's a negative slope and a negative slope. Alright, what about this? No calculator answer. Give the sine of cosine 120. Alright, so let's think about this. 120 degrees. Here's 0, 90, 180. 120 is somewhere in here. And we're asking for the x value. The x value would be to the left of the origin, therefore it is negative. Well, what about sine negative 5 pi over 6? Okay, if you would convert that into degrees, you would find out that's a negative 150 degrees, which is going to put it over here. And we're talking about a y value. We are below the x-axis, therefore it is a negative value. What about 7 pi over 4? Tangent 7 pi over 4. Let's see here. In degrees, that's the same thing as the tangent of 315. We've got 90, 180, 270, and it must be in quadrant 4. So the slope of anything in this particular quadrant is going to be a negative. So all three of those ended up being negatives. Find the location and then understand whether it's an x, a y, or a slope, and identify whether it's positive or negative. Okay, here's a couple questions that I would like you to evaluate. So no calculator on these. You won't have one for the quiz for stuff like this. Find the location, negative pi over 2, tell me the cosine. Find the location for 180, tell me the sine. Find these locations and tell me the individual parts that you need to, that I'm asking you for. Alright? Remember, these are not coordinates. You'll find a coordinate and you'll identify the x value, the y value, or the slope of that line. Okay? See you in class.